We're now ready to put all of this together. We found the 5-number summary. We then used the 5-number summary to find outliers. And now we're ready to create a visual, a graph that contains all that information. What is this graph? Well, it's called the box plot. But some historical facts. The box plot, the way it was originally mentioned, it was a plot of the 5-number summary. Then once we wanted to determine outliers, they created this other thing called the modified box plot. The modified box plot shows outliers. If there's outliers, it will show up different. It will create the graph will look slightly different if there are outliers. But if there are no outliers, the box plot and the modified box plot look exactly the same. I mentioned this because sometimes you see old software and sometimes this might still be used. And they'll say, do you want the box plot or the modified box plot? What happened was that most people wanted the modified box plot. So after a while, people, I'm guessing, this is totally guessing my part, decided to go, well, why do we keep adding this word when all we care is the box plot anyway? So then books are now just calling this the box plot. But if you use software, you'll have the ability, sometimes it's a little checkbox, sometimes it's the default, but there's a little checkbox that says, do you want to see outliers? Or another thing that we'll say maybe is, do you want to use fences? Fences is the upper and lower fence. And all of a sudden that means that you want to see outliers if anything, if there are any. So in other words, you're doing the modified box plot, but it will not say modify, it will just say box plot with some features in it. So a box plot is a visual representation of the 5-number summary. First, you need to draw a number line. So without a number line, this is incorrect. You need a nice number line. You mark each of the 5 numbers with a vertical line. As a matter of fact, I'm going to take that back. You would if it was a box plot. Exactly correct. But if there's outliers, you may not do this. The vertical lines are for certain Q1, 2, and Q3 all get vertical lines. The other ones, minimum, maximum, may get vertical lines or not, depending if they're outliers. However, oh, there it is, the clause. However, if there are data values that are considered outliers, then we give those special symbols. And what are those special symbols? It could be anything. It could be like a little star. It could be a little box. It could be an X. It could be anything. If you see, if for example, there's the bottom side has outliers, then definitely the minimum one outlier. So you wouldn't use a vertical line. You would use a little star to mark it. And any other data value that is an outlier. So I'm going to draw, as I mentioned, a number line. I don't have data right now. We'll get that in a minute. Just to show you what it's supposed to look like. And I'm going to draw another one here. Same one, same situation. So I'm going to make up some values, and then later we'll use actual data values. So I'm going to say Q1 here was 40. Median, Q2 is 45, and Q3 is 60. I want to make it nice numbers. So for this data set, these are the values. What about this data set? I'm going to say that Q1 continues to be 40. I'm going to call, let's see, I'm going to call the median like 42, so a little different. And then Q3, 50. So notice I've drawn 3 vertical lines for each one, and then encased them in a box. So this part is the box and box plot. So notice the box plot part is the middle 50%. So now we get to see how the middle 50% is spread out. You'll notice that area does not mean quantity. How much of the information, the data is between the median and quartile 3? 25%. How about between Q1 and the median? 25%. How about between Q1 and Q3? 50%. So for these two data sets, I see that the spread of the middle 50% is larger than the one with no outliers compared to the one with outliers. This has half of the spread that this one has, half the spread than the other one. Now, let's say that the maximum is 80. That's the max for this data set here. So now I'm looking at this. Now let's kind of visually track the IQR. The IQR is 10 here, right? So 1.5 IQR then would be 1.5 times 10 is then 1 full 20. That's 20. And then half of 20 is 10. So 20 plus 10 is 30. So when I mark here, here's my Q3. I go Q3, and I'm walked from Q3 1.5 times the IQR, which is 30. So 10, 20, 30, and this is the position of my upper fence. But I just said the maximum is 80, so that means that 80 is not an outlier, so it gets a vertical line. And then I extend this a line towards it from the center of this box to that. I extend it, and this is known as a whisker, this line. So where does my whisker extend? To the maximum, because there are no outliers in this data set. What about this set here? In this case, the IQR equals 10. So again, from here to here is 10. So 1.5 IQR is going to be 1.5 times 10. So this one gives me, see, 1 full 10 plus 5, that should give me 15. So where is this at? So 50, 10, 65. So 65 is where, when I add Q3 plus 1.5 IQR, which is 15, it gives me 65. So this is the location of the upper fence. Now, the upper fence is never part of the graph. Never, 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 never graph this, okay? So the upper fence, I'm just doing it here for educational purposes, but there's no markings for the upper fence. There's no need for it. But that means, again, the data, let's say the maximum here was also 80. So now 80 is outside the upper fence. It gets a special symbol. And let's say there's another data value. Like this 75 is another data value. So this would get this a mark that is also an outlier. There's another value, there's an outlier here at 70. So there's 3 data values that were bigger than 65. So these are all outliers now, and they get their own special mark. But where do we end then? The whisker. A mistake people make is that they want to end the whisker at the upper fence, and that's incorrect. The upper fence is never part of the graph. They're used to indicate those numbers that are outliers and those numbers that are not. So now I need to find the most extreme data value that is not an outlier. And let's say that it turns out to be 60. One more data value here. So it goes 60, 70, 75, 80 when I'm looking at my data. So 60 is not an outlier. It's the last most extreme value that is not an outlier. So that's where my whisker ends, at the last data value that is not an outlier, the most extreme thing that doesn't reach the outliers. And now I mark that and extend my whisker. And there you go. What about the lower end? Let's say that on this side, the lower end was 22. So 22 is somewhere here. Okay, but then again, when I go 30, and I go 30 from this position, I got 10, 20, 30. So the lower fence is right there at 10. My minimum value is 22. So that's not an outlier. So then I extend again my whisker towards that line. So in this set, this set has no outliers. So that's what it looks like. This is what the box plot looks like. So the box plot normally, and so what I've graphed is the 5-number summary: minimum, Q1, median, Q3, and max. And so that's what the box plot used to be. But now we want to show outliers. But if there are no outliers, it just reverts back to the 5-number summary. This one is almost a 5-number summary, but with bonus features. So now let's say that this is also 22. It is the same minimum for this one. But I go 15. So where's 15? 15 is 10, 15, 15. So 25. But I said the value here is 22. So it turns out 22 is also an outlier in this lower end. So it's going to get the same special symbol. But now again, I need to find what's the next data value. Let's say that when I'm looking at my data value, there's a 39, a 38, 38, 37, 33, 32, and then finally a 30, and then 22. So if that's the case, 30 is my last data value. It gets marked. So there's 30, and then there's finally 22. And 22 is an outlier. 30 is not. Those are other numbers between here. But then this thing the whisker extends towards 30. And there you go. That's the modified box plot, or just a box plot. Now they're calling it just a box plot. That shows outliers if there's any. So note the upper and lower fences are not part of the graph. I did this here just for educational purposes, but there's not marked. The whiskers in the box plot end at the location of the most extreme data value that is not an outlier. And I'm going to add another thing, respectively on either end. The area in a box plot does not depict quantity, like frequency. Instead, it depicts how much space we have to spread out 25% of the data between the quartiles. So 25%, 1/4, whatever you like. But that's all that's happening. So see how this area right here, it doesn't say that this area contains more data than this area. That's not the way you should view it. This area contains exactly the same amount of data that this area does. And this area contains the same amount of data that this area does. And this area contains the same amount of data that this area does. 25, 25, 25, 25. But this 25, I have quite a bit of room to dump my numbers by 25% in this range right here. And this one's not too far off. It's a little bigger, but this one's just as big. And I have 25% room to dump in 25%. While this one is very tight. I have to dump exactly the same amount of information between this number and this number, and so on. So area here depicts how tight or spread out the information is. So having said that, let's look at the US population data along with a histogram of the US population. So we can see, notice this is going to be, this distribution here is right skew, and it's pretty severe. So it's right skew, unimodal, but that's have some severe right skew. So clearly this is an outlier. This is an outlier. That's an outlier. Is this an outlier? Well, it could be actually. This part is pretty tight, but we already kind of know the answer. There were only 4 data values. So these 4 are those data values. So I'm going to write down here just a 5-number summary one more time. And I'm going to do the same thing for the exam scores. Tight. Then I'm going to write down the fences that we found. I think the upper fence, clearly there's no outliers in the lower side. Look how tight that is. But on the upper fence there was, it's 15.76 million. And here, there was nothing here. Notice the upper end. This is a left skew distribution. And there is no outliers in the upper part, but so I'm looking now for this graph as the lower fence. And the lower fence here, I don't know where it's at. Oh, there it is. I'm looking at the top of the paper because it's just sitting there. And it looks like the lower fence was 0.5855. And we can start this one. It's a little easier because I see the information just sitting above. So I'm going to mark the median. I always like to do that. It's about 0.11. Then I mark Q1, 0.76, so somewhere right there. Q3, 0.90, almost 9, I mean, just right here. And I create the box. Then I know there's I mean, look at this, look at the range here. There's no outliers in the upper part, so I just need to figure out the maximum, which was 0.924, no, 0.97, so close to 1. So somewhere there is so far my box plot. And now I know there's outliers in the lower fence, but I need to use the lower fence. And I already know what the outliers are because I'm looking, we calculated them when we did this earlier. So it looks like it was 0.48, 0.40, 0.408, it's almost 0.4. So I'm going to make this a little dot right here. That's the minimum, this right here. Then there was another data value that was also an outlier, and it was 0.54, so just under half there. And there you go. But now I need to figure out where to extend this whisker, but it's not going to be 0.5855. I need to figure out what is another data value that wasn't an outlier. So to that, I need to turn and look at the data. So but I also need to remember what this number is, 0.5855. So 0.5855, yeah, there we go. It's this number right here. I already have this one marked when we did this earlier. So 0.653. So these are my 2 outliers. Here's the lower fence, and there is the value that is not an outlier, but is the most extreme value that is not an outlier in the lower half. So 0.653, 0.65, 0.65. Come on, okay, it's about right there, 0.65. So that is 0.65. I mark it, I extend. There you go. That is the box plot. What we're now calling the box plot, and it shows outliers. What about this one? Median, 3.7. So I got 2, 3.7, close to that 4. I'm going to go Q3, 7.11. So this is 6, 7, somewhere there. Well, great. 1.35. This is 1. It's a little more than that. Again, my pen width is pretty big, so there's not a lot of precision here, but to get an idea. So once I mark Q1, Q3, median, I create the box in Boxplot. I know there's no outliers here, so I can just write 0.06 somewhere in there close to 0 and my little whisker. Now we also find, when I'm looking above, oh no, not here, these were outliers, but I need to get some more detail. So I'm going to just take and turn the video, take a look. Okay, I did that already, and looks like the one data value was 19. Again, this is rough. 22, so 21 was another data value. 29, this is 28, this is 30, so 29 is right here, halfway in between. And 39, so it's 36, 38, 39. They're my 4 outliers that I found. But now I need to figure out the next data value that wasn't an outlier. And so again, we're not graphing that upper fence, 15.76, 15.76, 15.76, 15.76. I need to go all the way back there. 15.76. Oh, there we go. Already marked. 15 was my upper fence. And there's my value that is not an outlier. And that's where the whisker ends, 12.80. So 12.80, 12.8, 12, this is 14, 13, 12.8, close to 13. Perfect. And that's Boxplot. Again, note that this contains right here 25% of the information. And you can see this rectangle contains quite a bit of that information. The next 25% is pretty tight. Even, this is really tight. It's a little less tight, but it's pretty tight. And then as we move to the right, notice we start relaxing a little. It starts getting a little more spread out, and that's what you see here. Finally, when we reach Q3, it starts to really spread out. And then we could determine that these 4 values were outliers, how bad the outliers. This mark tells us that, yes, the upper 25% had the biggest spread, but mostly due to these 4 values that are really extreme. They're way out there. The rest of it is, still more spread out than the other ones, but not as bad as we thought. Same with these exam scores. When I look at this box plot, I see that it's not symmetric, but it's not as, look at the range here, the range here, the range here. You can see there's some similarities. Yes, this one is the widest, but not terribly much more. I don't know, maybe like 30%, 40%. So it is. But then all of a sudden you get this massive change when you reach these 2 scores. So the next video, I'm going to do one more. And that one, it doesn't have any outliers. So you'll see we'll go through the same process, but there are no outliers.